Have you ever looked up at the moon and wondered how we actually got there? Or, turned on a faucet and thought about how we get clean water, just like that? It all starts with a simple question, right? A little spark of curiosity that makes us want to understand our world and then to make it better. So let's dig into that incredible journey, how our curiosity literally shapes the world around us.
So that's the big question, isn't it? How do you get from a simple, I wonder, to an invention that changes everything? Well, the answer is in this amazing partnership between two ways of thinking that are different, but you'll see, they're totally connected. Okay, think about it like this. Science is all about figuring out the rule book of the universe. It's the big why. Why do things work the way they do? Engineering, on the other hand, takes that rulebook and actually uses it to build things, to create, to solve problems. So one discovers the rules, the other applies them. They're really two sides of the exact same coin. But what's the one thing they both share? What's the common thread? It's this. It's having an active, questioning mind. It doesn't matter if you're a scientist studying black holes or an engineer designing a smartphone. It all kicks off with not just accepting things the way they are. It starts by asking why. All right, so let's start with the first piece of the puzzle, science. See, before we can change the world, we kind of have to understand how it works. Science is our tool for decoding nature's playbook, for figuring out the fundamental rules of the game. And over hundreds of years of asking questions, we've uncovered some absolutely mind-blowing rules. We understand motion because of Newton. We know the ground we're standing on is literally moving because of plate tectonics. And these aren't just cool ideas. They are the basic, non-negotiable truths that our entire reality is built on. Let's just take one of these, the law of conservation of mass. It's a pretty simple idea, but it's huge. It means you can't just create something from nothing, and you can't make something disappear completely. You can only change its form. This one rule is the bedrock of all modern chemistry. Knowing it lets us predict what will happen in a reaction, and that kind of predictability, well, that's exactly what an engineer needs. Which brings us right to engineering. So science has handed us the playbook. Now what? How do we use it to actually build a better reality? This is where engineers shine. They are the ultimate problem solvers who take all that scientific knowledge and turn it into real, practical solutions. Now, I've heard this one before. There's this common misconception about engineers that their job is just about, building stuff. All wrenches and blueprints. Not a lot of deep scientific thinking. So, what do you think? Is that true or false? Yeah, that's a big false. Engineering is so much more than just building. It's a deeply scientific process. It's a super systematic way of looking at a problem, coming up with a solution, testing it like crazy, and then doing it all over again to make it even better. It's all about constant improvement. And this whole systematic approach actually has a name. It's called the engineering design process. And no, it's not some random burst of genius. It's a structured blueprint that takes an idea from just a thought in your head to a real thing that works in the real world. It's basically the playbook for making cool stuff happen. At its core, the whole process really boils down to these three key stages. First, you've got to know exactly what problem you're trying to solve. Then you brainstorm and come up with some potential solutions. And finally, and this part is absolutely crucial, you test, you analyze, and you optimize your design to make it better and better. Okay, so that all sounds pretty good in theory, right? But what does it actually look like in practice? Let's walk through a really simple, hands-on example to see this whole process in action. Okay, let's start with step one, define the problem. Let's say our problem is we have dirty water. The goal, what we call the criteria, is simple. Make the water clearer. But we also have constraints or limitations. In this case, we can only use common stuff you can find easily. See how specific that is? We have a clear goal with clear boundaries. That's key. Now for step two, develop a solution. Sticking to our constraints, let's gather our materials. We've got a plastic bottle, some cotton balls, gravel, sand, and even some charcoal. The real engineering puzzle now is how do we put these together? In what order do you layer them to get the cleanest water possible? That's the design phase. And this brings us to the absolute heart of engineering, making things better through iteration. You build your first filter, you pour the dirty water in, and you see what happens. That result? That's your data. Is the water clearer? A little bit? A lot?
Based on that data, you ask yourself, how can I make this better? Maybe a different order for the layers. Maybe I need more sand. You tweak it and you test it again and again. That cycle of test, analyze, and improve, that is what engineering is all about. So we've got the scientist, the thinker who understands the world, and we've got the engineer, the doer who methodically changes it. But what happens when you get someone who is both, who perfectly embodies both of those mindsets? Well, that's when you get a true innovator. And honestly, there is no better example of this than the incredible Dr. May C. Jemison. Her story is just a perfect illustration of this powerful combo of deep scientific curiosity and a practical problem-solving drive. I mean, just look at her background. It's amazing. As a chemical engineer, she had this deep understanding of complex systems. As a physician, she understood the human body. And she brought all of that knowledge with her to become an astronaut, the first African-American woman to go to space. And here's the thing to remember. Her engineering training wasn't just another skill on the list. It was foundational. That systematic, problem-solving mindset was what allowed her to operate inside the incredibly complex systems of both medicine and space travel. And this just sums it all up so perfectly. Engineering isn't just about math and physics. It's this amazing mix of scientific knowledge, the creativity to imagine new possibilities, and just that relentless drive to test and tweak and improve until you get it right. It's how we solve the really big problems in the world. So from the simplest question you can think of to the most advanced technology, it all comes back to that curious, questioning mindset. Science gives us the rules of the game, and engineering gives us the playbook to make a winning move. The only thing missing is our own curiosity. So I'll just leave you with this thought. What problem, big or small, are you going to start solving?